All right, I think we are good to get started. Hi, and welcome to our webinar, uh, which is titled Three Ways to Identify Digital Transformation Opportunities in Your R&D Lab. My name is Julia Pascarella. I'm the marketing manager at Enthought, and I'll be your moderator today. Our speaker today is Alex Chabot-Leclerc, the Director of Training Solutions at Enthought. Alex is passionate about transforming people and the work that they do. He has taught the scientific Python stack and machine learning to hundreds of scientists, engineers, and analysts at the world's largest corporations and national laboratories. He holds a PhD and a bachelor's in electrical engineering and a master's in acoustics engineering. Without further ado, Alex, please take it away.
Thank you very much, Julia. So today I will talk about 3 ways to identify digital transformation opportunities in your lab workflow. So a few words about Enthought first. We've been helping scientists and engineers accelerate their work for the last 20 years. And the way we do that is by combining deep scientific expertise. Most of our people have a PhD or a master's in chemistry, physics, mathematics, with extensive software development capabilities. In addition to developing applications, custom applications, tools, Python packages, tool suites, we've also been training scientists and engineers for more than a decade on using Python scientific computing to increase their impact on the world. And we do that in a particular set of fields in the world of science and engineering. We particularly help people in life sciences, semiconductors, material science, energy, and chemistry and polymers. So today, to frame the discussion, I have an illustration here of a common structure of an R&D lab workflow. The idea is that the end-to-end workflow is in stages. It starts with a customer making a request on the left, or maybe an idea between you and your colleague. Then there's a set of stages that go from usually fast and cheap to expensive and slow. The first ones are usually digital and exploratory. It might be like some simulations, some data analysis, some modeling. Then it goes on to some typically physical stage where the production is very small, like teaspoons or maybe like a liter of a material or a small amount of culture. That process is usually slower and more expensive. And then what I'm calling a prototype stage, which is usually like a larger amount of material, a larger culture size, or maybe a device mounted on an electronic board for testing, something like that. And then at the end, it's handed off to a customer. So an important thing to point out on this graph is that between each stage, there's a decision gate where you must decide if the recipe, the material, the device is good enough to move on to the next stage. And at any point in time, if it's not good enough, you might go back to the next stage, or you might be completely sent back to the beginning of the workflow. And also at the end, once you give it to the customer, they get to decide if they're satisfied with what you've developed, and they might send you back all the way to the beginning to a different request. So our goal here is to get to the handoff as fast as possible, and then obviously to satisfy the customer request. So given this lab structure, here's how we at Enthought think of opportunities for digital innovation. So first, we start with something that's valuable, something that's already a valuable business output, something you're already doing. We don't recommend getting just a technology in search of a problem because we've seen that fail way too often. Then, given that valuable business output, we try to rethink the workflow, the output, with new tools in mind, with modern day tools. So the tools come after the workflow, not before the workflow. And the tools can be AI or machine learning. It might be automation, maybe custom hardware. It might be some optimization algorithms, better data management to, in many cases, enable AI and machine learning later. It might be some simulation to sidestep some expensive physical experimentation, or also education to help people and teach them how to use and how to develop using these tools. So the three types of challenges and the 3 types of opportunities that I'll talk about today. Types of challenges that lend themselves well to reconceptualization and the introduction of digital tools are hot loops, scattered expertise in variable processes, and high-risk transitions and customer drop-offs. So let's start with hot loops. So RD workflows, they're made of loops. And the hot loops, they're the loops that limit how fast you can iterate. Our goal is to be able to run as many of these loops as possible and to complete them as fast as possible. The loops happen at all the stages of our workflow, the early ones to the late ones to the whole workflow in itself. And they usually follow the steps of prepare something, prepare a simulation, prepare an experiment, run the simulation, run the experiment, run the culture, measure something, the density of the material, the reactivity of a chemical or compound or something like that, and then decide whether it's good enough and repeat. So on the right, I have examples of things that may be done at each step. It might be preparing input data for simulation, running and waiting for the simulation to complete, doing data entry after a measurement, analyzing that data, making samples, measuring those samples or the experimental results, often repeatedly, often in a manual manner. What we're calling data wrangling, in the sense of getting data from different machines, from different databases, from different places, bring it all locally, either in a centralized place or on your computer for further analysis, then often cleaning that data, processing that data, etc. So what we'd like to do here is to have a process to help you identify which of these steps should be targeted first. And for that, I suggest taking an idea from computer science that's called profiling. And the idea is to look at your workflow and to measure and keep track of how long and how often you're doing each step. So for each step, tabulate how long it takes end to end, the number of times you do that step in your workflow, how many people do it, and how much it costs. If you find complex steps that say this step takes 5 days, that's usually not very useful. It's usually better to break it down into smaller steps. That's what's illustrated in the middle here with this sunburst plot, where the green circle in the middle represents almost the entirety of the workflow, but it can be further broken down into these purple rings, and then the purple rings into gray rings, etc. And what you're looking for here is the largest consumer of time or money, the critical path. So the critical path is the slowest path through your entire workflow, where if you were working on something else, it wouldn't help you because that's the critical path literally through your workflow. And also if you have any causes of bottlenecks and delays that usually affect this critical path. And it doesn't have to be super detailed. Sometimes just back of the envelope calculation like I have here of like how often you do something, how many people will tell you here, like this workflow, we spend 120 hours a week just doing X, or we're spending $7,000 a week running these experiments. And then, so this process, profiling, basically allows you to identify your valuable business output that we're then going to reconceptualize and pick different tools. So there are tons of things, tons of way of reconceptualizing. I picked 5 main ideas. The first one is automation. It can be tiny things like automating how files are named. So it's standard, easier to parse, easier to keep track of. Moving files around so you don't have to like copy paste, so you're sure files go to the right place. Automatically creating input data for your simulator, or automatically collecting the data that, say, machines are producing so that they automatically get in a central database, central data catalog, or something like that. So an example of automation, we had an engineer who attended one of our training programs who was regularly analyzing SEM images. And it could take him 24 hours looking at that image, like counting defects. So he built a little app where he could load the image, tune a few parameters, and it would do the same analysis in 6 minutes. So from 24 hours a week to 6 minutes for an image. Another approach is to build custom tools to streamline repetitive work or give you new capabilities. Easier data entry is one of them, an app that's designed for collecting data for that experiment. It will also help a lot for getting clean, consistent data, which can be used later for machine learning or just data analysis. Figure generation for reports or analyses. Sometimes something as simple as a small app where you just drag your machine data and it generates a plot for you can save you tons of time. Or you can point a similar app to a data file that will it will automatically parse the data, clean it, visualize it, maybe let you fit a model, helps you speed up your decision making. Or an app to help you screen your sample data where you don't have to do manual analysis of what's happening. It will tell you basically pass or fail of whether you should keep that sample. We had another engineer who joined our program who, after a 6-week immersion, he replaced a monster of an Excel spreadsheet that he used to parse log files produced by their machine. So he built an app where you drag the log file, it would automatically identify all the events, plots what was happening, the timeline, and help the engineers diagnose what was wrong with the machine. Since then, it has grown into a full suite of tools that's used throughout the company. Another strategy is rethinking workflows given modern technologies. So could you skip a step and simulate it instead? Or could you train a machine learning model to screen samples or predict how well something will work? Or could you make custom hardware with like a $35 Raspberry Pi and some off-the-shelf part to automatically like take photos of I don't know, an LCD panel or a wafer or something like that and do image analysis on it? Is there anything you can do that allows you to skip a step or to sidestep the physical world? Or can you parallelize what you're doing? Could you hire more people to do more of it? That's usually kind of expensive. If you're doing simulation, can you like get just a bigger computer with more cores? Can you learn about parallel computing? Or can you go to the cloud and use more resources there? In that case, we're aware that it can be hard, that in many cases, if you don't think of it upfront, it might require you to rewrite all of your code to be able to run in the cloud. So actually, we've seen this so often that we've developed a set of Python tools that allow you to keep the same code, whether you run it locally or on a cluster. And finally, you need a way to share what you've built, because sharing is the multiplier of impact, especially if you have, multiplier of impact. That's one of the biggest payoffs. Again, we know this can be tricky. Sharing an Excel spreadsheet is not really the solution. So we've developed a set of tools, again, that allows you to publish apps and Jupyter notebooks, basically like an app store. So the end users, they don't need to know any programming. They don't even need to know that the app is written in Python. It enables developers to quickly like iterate and improve applications and share the impact of what they're doing with their team. So this moves on. This brings us to our second strategy or type of opportunities, which I'm calling scattered expertise in variable processes. So in this case, I'll start with a story. Another engineer that was working with us, and part of his workflow was coating silicon wafers. And in order to do that, he had to make the coating material, drop it on the wafer that was on a platform, spin the platform to spread out the coating material, dry it up, and then measure the thickness. So as an expert, he could get to optimal thickness in maybe 20 wafers. He would have to run this process 20 times. But then he took a step back and looked at his whole lab, and he saw that non-experts could sometimes need 40 or 50 wafers to take the reach the same optimal thickness. So that's an example of scattered expertise. Different people get different results in different amounts of time. And in his lab, he had 10 people doing this, doing it 2 or 3 times a week. So his calculation with his lab was spending 100 to 400 hours a week optimizing the thickness of wafer coating. So he wrote a little app that you input the measurement from the machine, and it would solve a simple optimization problem based on a mathematical model of the process that he had sort of in his mind and from literature. And the app would tell him what recipe to try next. And according to his estimate, that would reduce the number of iterations required down to 5, both for experts and non-experts. So that would save them tons of time and of money, and also remove dependence on expertise. And if the model gets better, everyone gets better. So the concepts that he applied here to solve his problems were to standardize. He standardized data entry, he standardized decision making, he centralized, he collected all of the wisdom in one place so that he could ask his colleagues, the other experts, like, hey, what other variables are you considering in when you're trying to optimize the coding? Can we capture that in the app? He shared it with his colleagues. Again, that's the multiplier of effectiveness. And then again, he captured the improvement by asking his colleague how he could make the app better for everyone to benefit. And these concepts here, they're equally important to solve the variable processes issue. So when different humans, they look at the same image, they look at the same video, they look at the same, I don't know, subsurface scan, and they all look at it and they make different measurements. That creates noisy and unreliable data, and that makes all further decision making after that harder. And having reliable data, clean data, is absolutely crucial if you want to use any kind of machine learning or AI down the line. And finally, for a third type of opportunities, we're calling them high-risk transitions and customer drop-offs. I'm going to go back to our lab workflow again with our decision gates at each stage. So here we decide at each gate if the recipe, the sample, the device is good enough to move on to the next stage. And again, what we want to do is get to the handoff as fast as possible. But at every stage of our workflow, there's a risky transition from one to the other. The next stage, the next process is usually slower, is usually more expensive. So that leads to bottlenecks, right? A backlog of things to process. We have a bunch of good ideas during digital and exploratory. We put them in the queue for pre-prototype, and then we might be waiting 2 weeks for them to be processed. Another thing that happens that we've seen a lot in materials is when you change the scale of production from like a teaspoon to a gallon or something like that. Often you need to change the variables, you change like how you mix them, the temperature, these kinds of things, maybe even aspects of the recipe. So there's a lot of churn there to rerun the same process in search of the best parameters to tune your recipes. And that creates also, obviously, a bunch of waste at the interface between these stages. So that's it for risky transitions in the workflow. Customer drop-offs. So we go back again to our workflow. So the more time it takes us to develop that new device, that new material, that new cell culture, the more money it's costing us. And the more the customer waits, and the higher the chance of our competitors getting there before us, or our customers looking at our samples saying, I don't think you'll make it to the end, I don't think you'll be good enough, them just dropping off and abandoning your candidate product. So in fact, many of our clients tell us that time to market, the time between the request and handing off a product, is one of the most important variables, in that what seems to be a small change, maybe like 5, 10, 15, maybe 20% shorter time to market, would allow you to capture a a huge chunk of the market. So much so that they come to us asking for a magic black box model, say, hey, Enthought, can you make me this magic thing that maybe we input some data, customer requests, and it gives us the recipe or the instructions for the desired end product. In about 105% of cases, that's impossible or too far off. Maybe in 100 years, we would need something like a world simulator in some cases to solve that, or at least tons and tons of data. But in many cases, the data is scarce or it's way too expensive to acquire, like thousands of dollars per data point, and they would need millions of data points. So that's not an option in the short term. So actually, these issues with data, this is a good example where hot loops and automations are a really good way to reduce the cost of data acquisition. So instead, we go back to our process of identifying valuable business outputs, and we think about how we can reconceptualize it to improve the business. So for risky transitions, and customer drop-offs, one of the seemingly simple and impactful method that we've seen is better screening tools. So instead of trying to develop a model that will predict how good the output of the process will be, how I don't know, heat resistant the material will be or something like that, which is a regression problem. Instead, turning the model into a classification problem where instead of predicting how good it will be, predict if it will fail past the next stage. So if you know that it's going to fail, then you don't need to pass this sample through your more expensive process, so you'll save time and money. Obviously, you need to tune it so that you don't miss opportunities. But in many processes that we've observed and companies that we worked with, there's a chance there to reduce waste and minimize drop-off and maximize throughput. In fact, we had one apprentice who worked with us for a material science company who designed a new measure and built an app to measure it that helped predict failures of their material in the customer's process. And they went back through their archive of data and showed that the metric, if they had used it in the past, it could have reduced the number of manufacturer client iterations by up to 90%. So that would have likely led to reduced time to market, reduced time to answer the customer's request, and hopefully more business. Another strategy is to exchange precise, slow, and usually expensive measurement devices for things that are maybe a little bit more imprecise, but are much faster and cheaper. That also allows you to collect more data for better data analysis and better machine learning. We've actually built a little robot with like an off-the-shelf like thing that you can order on Amazon, just a camera with a nice lens, a Raspberry Pi, some railings, some motors to automate the measurement of electronic panels. And the device cost us maybe a few $1,000s of parts compared to like an industrial microscope that would cost like tens of thousands of dollars. And it would be much slower, it would have to be manually controlled. With our little basically robotic platform, the engineers could just put in their device on it, press record, it would move the thing around, take all the photos, do all the image analysis. So what these strategies enable you to do is hopefully get to market faster, have a better throughput through your process, fewer delays, less churn, less waste. And you might wonder like why we're focusing on efficiency first with digital tools. Because they're usually an easy place to start. It's easy to think about, but also efficiency creates margin. And once you have margin, you can pick up from errors or catastrophes. When you have margin, you can work on something else. You can work on the next valuable problem that you don't have the bandwidth to work on right now. It also increases resiliency. So just think of all the companies that were digitally ready in the last 18 months and how they dealt with COVID better than companies that required a lot of in-person manual labor. And also, if you rethink of your workflows and introduce a lot of digital tools, at some point you have a critical mass of tools that can be recombined in new ways to solve new problems or take advantage of new opportunities. So if this inspires you or it reminded you of an idea that you have of something you could do in your business and you would like to get started, you would like to do this, but you're not sure where to start, we have put together a program to help you do that. So why did we do that? Why did we build our our applied computing program? Is because we know from experience, from talking with clients and from reading business magazines, that there are enough people in the world with digital skills for the amount of work that needs to be done. We've done our part. For the last almost 2 decades, we've trained thousands of scientists and engineers on using Python in scientific computing. But especially in the last 4 or 5 years, we've been running a 6-month-long program called the Technical Leaders Program as part of a larger engagements. And these 75 people or so that we've trained, they've developed dozens and dozens of apps. One person built a new simulator that allowed his business unit to go into new markets. We've changed the day-to-day work of almost all of these people. Some of them have become project owners. Some of them have won awards in their company. Some of them are now teaching their colleagues how to do this. So we have a, quote, enterprise grade program, but we realize that we're not going to it's not enough to change the world. We want to make it available to more people because we've seen the power of individuals to change their work and their organization, and the world needs more of that. So what you'll get with this program is help to apply what we've just talked about, these strategies to identify problems, to identify opportunities. We'll help you diagnose the current state of your workflow, define a new desired state with digital technologies, and help you make a plan to reach it. You will learn how to solve it, then you will work on solving it, and we will help you solve it. You won't be alone. You'll be working side by side with an Enthought expert. So the whole program is about 200 hours of active time, but 60% of this you will be working on your business, not on some class material. You'll just be doing work. We made this for scientists and engineers who already know some programming and who want to get better at leveraging digital innovation to bring change to their workflow, their team's workflow, their company. The program costs $17,000 if you register before July 23rd. And just to give you a sense of what it's worth. So if you have an idea of something that could save you, your team, 225 hours of work over the course of a year, that's just 4 hours a week, the program would pay for itself in less than a year. So this is not a program with some promise of just, you will be better. There's clear return on investment that you can see very quickly. And that's just like the project that you're working during the program. This doesn't account for all the other things that you'll be able to do after that. So the next run of this program starts August 23rd. It'll start off with 2 weeks of classroom training. So just get you a foundation, make sure you know the tools that you need to solve your problem. Then we'll have 5 weeks of a standard project that we call the practicum to solidify what you've learned. And in parallel of that, we'll work with you to select a project that has the biggest potential impact and the largest chance of success. And then it will end with our 3-week apprenticeship where you'll work on your business problem full-time, and then an Enthought expert will work with you on a daily basis and help you solve the problem. So if you want to learn more, you can check out our website at enthought.com/ACP. And we've also made a brochure that you can share with your manager if you want to have a discussion with them about investing in you and in the business and communicate the return on their investment. We'll share that brochure along to everyone who've signed up. for this webinar. We'll send it along with the recording. So to sum up, I presented 3 strategies to help identify digital innovation opportunities in your lab workflow. There were hot loops, scattered expertise and variable processes, high-risk transitions and customer drop-offs. And if you want a head start and you want to start doing that in your business, you want help identifying these opportunities in your business, I hope you'll check out our applied computing program. And that's it for me today. And I'm very thankful that you decided to spend some time with us.
Thank you. Thank you for that awesome presentation.
Certainly.
It looks like we have a few questions coming in.
Okay.
Let me take a look. The first question, why start with these 3 strategies to identify opportunities?
So that's a really good question, actually. As most things in the world, there's an infinite number of places where you could start. But the idea is we assume that you need to keep the lab running while you're transforming, that you cannot just like go off and start doing something else. So by identifying things that are already valuable, you know that if you make them better, faster, more efficient, that has a bigger chance of success, and that will sort of obviously pay off later. The alternative, which is just go in with the new technology in search of a problem, usually, as I said earlier, that tends to fail. The other reason is that these strategies, I've talked to them in the context of like one lab loop, but also an entire business. They work at all scales. You can do that. You don't need to convince anyone else necessarily to do that. You can look at your own workflow. Or if you want a larger impact, you can talk to your colleagues or to your manager about how to do it on your team. Or if you're a manager, you can talk to your VP or director and talk about how you do this at the business unit level. So it's a nice set of tools that work at different scales in the business.
Awesome. We do have another question, and that is, how do I know concretely where to get started?
Like I said, if you start with your workflow, then you get to skip asking, you get to skip talking to people. No, I'm kidding. But you look at your workflow, there's bound to be a bunch of opportunities of things where, like, if you can actually, here's one tip. It seems simple, but if you're working on a computer and doing a bunch of things at your computer, record your screen as you work for maybe an hour or two, and then play it back at like 10x. And you'll see the things you do over and over again. You'll see your habits, and usually this sort of taking a step back will allow you to identify places where you could maybe write a little script or write a little app that could save you time. If you have 2 programs and you're in the middle, taking data from one, bringing data to the other, look to see whether they have an API or an interface where you can have them talk to each other without having you in the middle. So you can now control your computer at like a level above that. So you can, I don't know, go off and drink coffee, or go off and think while the computer is doing things, think about the next most important project that you could be working on.
Great. I think we have 1 or 2 more questions coming through. One of them is, this seems like a big program. How do you recommend that we go about convincing your boss to invest in this, in digital transformation?
That's a really good question. So whatever you decide to do regarding investment, you have to keep your eyes on the prize, which is the business itself and what is needed. So any investment, whether it's in training, whether it's in technology, has to be you have to think about it in terms of how it's going to affect the business. So if there are inefficiencies in your lab, like some of the things that I discussed, like the hot loops. You have to be able to explain to your colleague, to your manager, how streamlining or getting rid of the efficiencies will allow you to like shorten the time to market, maybe win more contract, or make the cost of production lower so that you get better margins. And yeah, depending on how your lab works, the story will be different, obviously. But that's a good way of convincing managers typically, which is to tell them things will be cheaper, faster, we'll get more customers. Um, yeah, that's usually a language that managers like to hear.
Definitely. I think that's all the questions we have for today.
Okay.
So I just wanted to say thank you everyone again for joining us. If you have any additional questions about identifying digital transformation opportunities, or you'd like to learn more about the Applied Computing program, please find us on our website. We'd love to hear from you.
All right. Thank you, everyone.